Well, good morning, good afternoon, good evening to everyone, wherever you may be across the world. And thanks for joining us live here today for Serverless Office Hours, streaming live on the AWS Twitch channel and also the Serverless Land YouTube channel. My name's Julian Wood. I'm a developer advocate for serverless at AWS, and this week is API Gateway Week. And I am super happy to be joined by Ronan Prenti, who is a senior solutions architect, and Zach Burns, a cloud support engineer. Ronan and Zach, welcome to Serverless Office Hours. First time, I think. So thanks for jumping into the fire.
All good. Thanks for having us.
Julian.
Excellent. And we always say we're streaming this at 10 a.m. Pacific time. The European people in Europe are taking this over. I'm based in London, and Ronan and Zach are based in Dublin. So eventually we are wrestling the reins away from Eric and the rest of the lot on the other side of the pond. So we'll always do much better than them. I mean, that's just obvious. So, but enough silliness. Ronan, I mean, you're a senior solutions architect, but I think you've come up through the ranks and you've actually been at AWS for quite a while. What's your sort of AWS history, and what do you do today?
Yeah, hi everybody. My name is Ronan Prenti, and I'm a solutions architect at AWS. I joined AWS back in 2016 as a graduate in the support team. So I started off there. I worked with Linux and networking services, so things like load balancers, EC2, then moved into the serverless team in the support org. So in there, I was working with services like API Gateway, Lambda, SQS, SNS, and a lot of those core services that you might build a serverless app with. And then from there, moved into the solutions architect role, where I work with startups all the way to enterprises and everybody in between to help them build on AWS. So I'm really happy to be here today, and thanks for having us, Julian.
Pleasure. Yeah, Zach, and you're a cloud support engineer. So I mean, to me, that seems like one of the hardest jobs at AWS, when people basically phone you up with their questions and their comments, and you meant to know everything about everything on AWS. That seems a hard job. How have you come to be at AWS? And yeah, how do you manage to handle a complicated job like that?
Well, hi Julian. Hi everyone. I'm Zach. I'm a cloud support engineer and an API Gateway subject matter expert. So I've been in AWS about 2.5 years. So the first year of that, I was actually an intern. So I worked with Ronan, as he said, in the serverless team. So that's how I came to know Ronan. And then for the last 1.5 years, I've worked in premium support, where again, I work with services like API Gateway, Lambda, SNS, SQS, a whole host of really cool services that we get to learn about and troubleshoot on a daily basis. So yeah, there's an extremely large volume of services. Everyone knows that, and it's impossible to know everything. So the way you kind of go about it is people are your best resources. So you just got to know who to ask, and what questions to ask, and you'll always get the right answer. So that's kind of the approach we take in premium support.
Well, that's
thanks
perfect.
for having me today, Julian.
Well, I'm super happy to have you here today, because I know a little bit about API Gateway, but as with all Serverless Office Hours, the questions are open in the chat. In the chat, send them on your way. Can be about today's specific topic and API Gateway generally, and then we get Zach to answer the questions. I don't have to look like the person who doesn't quite know, and we've got a subject matter expert from the support team. So that is super cool. So yeah, just having a quick look back on the last week of serverless, what's happening in AWS land, and then we'll dive straight back into the topic. Last week we had Eric Johnson and Justin Callison from the Step Functions team, and they were talking about the AWS SDK service integrations. And this is wicked. That's all I can say. Basically, you can use Step Functions to integrate with any AWS SDK call, and it's something like 9,000 different API calls and 200 plus services. So all those kind of times where you needed to have a Lambda function to be able to pull something from somewhere or add something to somewhere else, maybe you're talking to recognition, or maybe you're talking even to DynamoDB or something like that. Now you can do that natively with Step Functions. So have a look last week on the Serverless YouTube channel. The videos are all over there, and Eric and Justin did a great job going through that great new functionality. In terms of what's new in AWS Serverless over the last week or so, Lambda has IAM support for MSK and as an event source. This one I thought was interesting for S3, that a lot of people using Lambda functions in VPCs and VPC flow logs. Ronan and Zach, or Ronan was saying with his networking background, VPC flow logs are a super important way to be able to log all the stuff that's going on, and now it supports Apache tripping over my words already, Apache Parquet and a whole bunch of other stuff. So that's useful if you're doing some kind of log storing for your VPC flow logs, AWS Batch and a new connection with step functions, and then AWS Amplify, which is the front-end framework, which also does some back-end stuff. For JavaScript now supports also resumable file uploads for storage. And the Amplify team is just adding more and more stuff all the time, so that is super useful. And step functions we covered. Just looking back over some recent compute blog posts, the Q3 stuff, which James Bezic, that's all of our team and all the people across AWS who are writing blog posts, they are putting their content there. It's a great place to find everything. Batch and step functions, a blog post from Dheeraj. Amazon SNS subscriptions, auto-scaling container workloads. That's also super useful to be able to use SNS, fan out, and being able to have some super scale with that. I'm just going to talk about the bottom two with James first. Lots of stuff with S3 that James is the expert on. Recursive invocations with S3. I'm sure the support team gets lots of calls with what's going on. My Lambda function is recursively calling stuff from S3. How can I fix this? And so James has got some really simple and really practical tips for helping with that. And also he's written a cool blog post about a difference checker. So this is using S3 if you've got versioning on and you want to find out in a text file, for example, what's different within the text file. You can just run a Lambda function and get those two different versions of the versioned text file that's been uploaded and find out what is the difference. And then I do want to call out Jerome van der Linden's blog series, Operating Serverless at Scale. This is the third one. This is Keeping Control of Resources. Really a phenomenal series he's been putting together. And this Keeping Control of Resources has got a good sort of security angle. And it's got a great story about you want to empower your developers to be able to deploy serverless services. But what happens if you've got a central team that maybe vends or creates IAM roles? That's going to be tough because you want the developers to have the flexibility, but you also want to have the control. So Jerome goes into this blog post all about setting up those guardrails to be able to give your developers that agility and also be secure from an organization. So that's what's been recently happening with over the past weeks with the blogs and everything. But yeah, on to today, we're going to be talking API Gateway, and this is some great work that Ronan and Zach have been doing, which is all about migration tips for API keys. So I'm just going to switch over to Zach's screen, and then Ronan, I think you are kicking us off with a bit of an explanation about what we're talking about.
Yeah, cool. I'll kick it off. So I guess the whole purpose of the stream today is really to talk about that blog post that Zach and I wrote. So I guess as a solutions architect, I'm talking with customers all the time. Like I said, they could be startups, SMBs, all the way up to enterprises. And a common pattern that I'm seeing is that customers want to migrate into Amazon API Gateway, whether it be for the vast amount of features that it has, the cost savings that it can bring versus other vendors, etc. So typically it's a very handy thing to do. You can represent your API as a Swagger template, open API, and import them into API Gateway. But there are some vendors out there that allow you to build your API requests slightly differently. And the purpose of this blog post is really, and Twitch stream is really to explain how can we handle that? How can we facilitate that migration almost invisibly to the clients and then move towards kind of a better way to operate your APIs? So for anybody who doesn't know what API Gateway is, you've landed on this stream, you're like, what the hell are the guys talking about? API Gateway, I look at it as almost like a front door into serverless applications. And it's not just serverless. You can integrate with AWS services directly, load balancers, different HTTP endpoints, whatever you want really. But it's very common for people to build serverless applications behind API Gateway. So like I said, I was working with a bunch of customers and a common ask was, we want to migrate into API Gateway. But we currently send our API keys as a query string. So that means they're sending the HTTP request, and in the URI, you'll see a question mark, API key equal ABC123. If you don't know what API keys are, they're a great way to kind of measure and throttle usage on your API. So I could give an API key to Julian, and I'll say, hey, Julian, you are allowed to access my API, and you're allowed to hit it 5 times per day, right? I could give a different key to Zach, and I could say, Zach, you're allowed to hit it 50 times per day. And they must give that key in every request that they make to the API. So I was seeing other vendors allowing people to build their APIs, so they were sending the key as a query string. Out of the box, API Gateway doesn't allow that. Okay, so API Gateway allows you to accept an API key, 1 as a header, or 2 as a response from a custom authorizer. So myself and Zach will get into that as we go along. And I would encourage you to keep asking questions. Julian can field some of them. We can answer them on the stream, etc. So I guess important thing to note before we start is this solution is purely meant to be a short-term measure, right? It's to facilitate that initial invisible migration so that you can get your clients pointed at API Gateway, start making use of the features that it brings, and then you can migrate to sending your API keys as a header. Why is that? Well, if we think about it, if you're sending those requests out from a server with the API key as a query string parameter, there's always a possibility that those could get logged on the server logs. So we want to avoid that where possible. And we want to put the API keys back into a header in the future. So then the whole payload of the request is encrypted. So any questions so far, Julian? Are we good?
No, I think we're good from the questions. Yeah, just something I wanted to ask. I just wanted to sort of reiterate on that point that yes, this is a migration, as the blog post and your explanation is, and yeah, API keys are going to be personal for every single customer. That may not necessarily be a security implication, or just a security implication rather, but it could be an availability implication, because if somebody grabs your API keys, for example, when you have allowed 5 requests per day, if somebody is going to use up those 5 requests a day, they're basically going to do a denial of service against your APIs. So even though we think about API keys, I presume, as an identifier, there are security and availability things to think about with that.
Yeah, and look, we don't recommend to use API keys as your sole auth mechanism. Like, we have a bunch of options that customers can use. So you can use Cognito user pools, you can use custom authorizers to handle custom JWT tokens, and so we have a bunch of options there on the API gateway level. So any questions on what's available, let us know. We'll be happy to help. So I guess, look, but before I go on and let Zach dive into the code and how you can deploy the solution, I'll talk a little bit about the solution itself, okay? So from the blog post on the screen in front of you, you see a diagram, and we see the clients here. So imagine the client is Ronan. Ronan is sending the request to API Gateway. So this is assuming we've built out our API Gateway that accepts the API key as a query string, okay? When the request reaches API Gateway, you'll note at the top there, we have the API key sources, the authorizer. So like I talked about, API Gateway supports 2 different types of, 2 different sources for that API key, the authorizer and the header. So in this case, we're going to choose authorizer. So that setting kicks in. You'll see step number 2 is basically API Gateway is taking the payload of your request and it's sending it to a Lambda function. That Lambda function is what we refer to as a custom authorizer. And what that allows you to do is pretty much anything you want, right? So you can take a header and validate that it's correct, take a query string like we're doing in this case, and pass back a policy to API Gateway to say, I'm going to allow or deny this request. What we're using it for in this case is, if you look at step number 2, we send the request. Okay, we send the request with the API key in the query string. That reaches Lambda, and then Lambda pulls it, essentially receives this payload which has all the information about the request. It pulls out that API key and it gives it back to Amazon API Gateway. And as Zach gets into it, we'll show you how exactly that's done. So that's kind of 3 and 4 talked about. And number 5 is API Gateway has received a response from that custom authorizer. And now we're going to validate that key. We're going to say, is Ronan allowed to, send the request to this API? Has he got requests left on his plan? And if yes, proceed to number 6. If no, well, you're not gonna get through. So that's really how the solution works at a high level. Anything I missed there, guys? Anything worth talking about?
No, I think you're good. I mean, I think the thing that I sort of picked out of that is that you're not actually building, in a way, any different API key management or a whole kind of other backend for managing these API keys through the transition. You're using the Lambda function cleverly to do a transformation of the API key that's coming in into a format that API Gateway expects. And so in a way that makes it much simpler. You're not, having to manage your own API keys in DynamoDB or having to manage them in some other database, or is that not the case?
That's absolutely correct, Julian. So look, there is an option there. Essentially with Lambda, you can do whatever you want at that custom authorizer level. We are still very much leaning on the usage plans that API Gateway gives us. I suppose an important thing that I totally forgot to mention is that if we think about an enterprise who may have their API exposed to thousands of clients who have API keys already, we might want to import them into API Gateway. So we can do that ahead of time so that when the requests are coming in, the API keys will work. So yeah, it's not a custom solution. We're relying on the managed stuff that API Gateway gives us out of the box. In this case, our API keys and our usage plans. Thinking about the future, so we were very clear to say that it's very much a short-term measure. We shouldn't really be sending the query string to the API key as a query string parameter. Looking forward, we would and we recommend to actually remove that Lambda function from the mix and send the API key as a header itself. So that's thinking long-term. So I don't know if Zach, do you want to add anything there, or are we good to kind of move on to some code?
Yeah, I think the most important thing here is to stress is that this whole thing is invisible to the client. They're sending the exact same HTTP request to probably the same domain name. There's just been some kind of a DNS cutover, and this is just to alleviate, I guess, the client to make the changes to inevitably send the API key via the header, like we recommend. So Ronan stressed that it is temporary, but the whole thing is invisible to the client. So that's something to consider or remember when we're doing this. But yeah, if we want to jump into the code,
let's jump in. We're always good for
awesome.
the code.
Yeah. So this is our blog post. We have links to our GitHub within it. And this is our GitHub page, right? When we want to get the code, we just do git clone and the URL, and we just put it into our local machine. So I'm doing this on a Cloud9 environment. Cloud9 is just like a serverless IDE, essentially, where you can develop and collaborate online instead of locally on an IDE. So I'm just going to clone this our repository into Cloud9.
Zach, is there any chance of just getting a little bit of bigger text? I know we're only cloning stuff in the command line, which hopefully people can follow along, but yeah, I know it's not the easiest in a browser-based IDE. Yeah. Even that is better. Cool.
Yeah, so that's just the command. It's just, the one before that. So it's just git clone and then that URL, and that will get you our repository locally for you to read and mess about with. And all I've done is that after that is just cd it into the folder. Into the
folder. Okay, so the URL is in the chat. So if you are watching live, one of the benefits of live, you can just copy and paste it from the chat. Maybe it's in the chat afterwards as well, but there you go. So you can follow along and you don't have to and find out where the GitHub repo is.
Yeah. So is that okay, Julian, size-wise?
Yeah, that is good. Even for my old eyes.
Awesome. Cool. So this is our template.yaml. This is just where we basically create the resources. There's nothing crazy going on. We're creating 2 Lambda functions and 1 API. So I'll just go through each and talk about what we did. So the first function we're creating is our auth function. So as Ronan said, this is our custom authorizer Lambda function, which where all the magic happens, essentially. I'll dive into the code and what we're doing within that a little bit later, but the most important thing is just that it's Python 3.8. You know, that this is not locked into Python. If you're more comfortable in another language, by all means, write the solution in that language. And this is just our backend Lambda function. So if the request is successful, API Gateway will then send the request to this backend Lambda function. And again, you're free to do whatever you want in that. We're just returning a hello world with, I think, the source IP. But again, you've got full development freedom to do what you want in this. So on this backend Lambda function, we've just defined an event. So when you think of the API Gateway console, you'll see like an event source. And that's essentially just the Lambda function resource policy, which says I give this service permission to invoke me. And all we're doing is telling this Lambda function that we're expecting to be invoked by API Gateway. By the API, we'll define below on the path /auth and the get method. So it's pretty simple. Again, not a lot going on here. So, stop here. So this is our API, the main where it all happens. So SAM offers I guess, a resource or a property called default authorizer. And for this, we've defined our request authorizer. A default authorizer in SAM essentially applies this authorizer to every single method and resource on the API. So if you import a Swagger template from, say, the old vendor, and has tons of resources and methods, it can be a bit monotonous to sit and apply this Lambda function to each and every method on the API. So this property will just by default apply the Lambda authorizer to every single method for you. And the same for the API key below. By setting this to true, we're saying that every request sent to the API Gateway must contain an API key, or else we'll reject it with the 403. That's a pretty common issue we see within support, is that customers are saying, you know, hey, why am I getting a 403 forbidden? In some cases, there will be like they'll not realize they have API key required to true. So a method will be expecting an API key, maybe accidentally, but because the request doesn't have one, they'll be seeing a 403 forbidden. But that's essentially what that setting does. So on down to the authorizer, where we're defining the actual, so there's 2 things we create the Lambda function itself, but we also have to create an authorizer resource inside of API Gateway, to which we, I guess, apply that Lambda function to. So API Gateway provides 2 types of Lambda authorizers. We can see we're using the request type authorizer. So there's request type authorizer and there's a token type authorizer. So a token type authorizer would be better used for like a JWT, because its payload only really has the token that you're sending from the client, and it has to be a header. So when you're creating this or a token type authorizer, you'll specify the header name in which that token will be sent. You don't really get to specify like query strings or path parameters or anything like that. It's strictly for a header and a token sent in a header. We are using a request type authorizer, which gives us a lot more information in the Lambda about the request, who sent it, where did it come from, and essentially, well, most importantly, the API key from the query string. So we get all this information to perform our custom logic in. And probably one of the really good features of this is the ability to specify an identity source. So for our identity source, we've specified that we're going to be expecting a query string with a value API key. So what does this mean? If the client sends a request without the specified identity source, in this case, a query string API key, API Gateway will just reject the request immediately with a 401. So what that means the Lambda function in the backend won't even be invoked. The authorizer won't be invoked. So you're saving a lot of money and you're billing by ignoring requests that are useless essentially. There's no point invoking a Lambda function if the query string isn't in the payload. So that's just a good way to sort of eliminate it could be malicious, it could be bot attacks. API Gateway is just going to reject them all unless they have this identity source.
Yeah, so this is a good point. I like the way you've showed it here. That is to try and think of API Gateway as your gatekeeper. And even though you're using a custom authorizer, in effect, you want to avoid running the custom authorizer for any API request that isn't valid. And if you can build that functionality into your API Gateway, which is pretty simple over here, just with specifying that a particular query strings need to be, API Gateway is going to be much faster. You're not going to be invoking all those custom authorizers which keep going no. API Gateway is just meant to do no straight away. What other kind of identities would you be able to specify for a Lambda authorizer?
Yeah, so for request type authorizer, you can specify query strings, you can specify a specific header, a path parameter, and you can specify more than one. So if you have a request from a client that sends always the same query string, the same header, the same path parameter, you can specify all these, and API Gateway will, they have to include all of them, and if they don't, they'll be rejected immediately. And one thing I forgot to add on that as well is you also don't pay for the Lambda invocation. API Gateway also doesn't charge for unauthorized requests, so you're going to save money on API Gateway and Lambda just by this identity source setting. So this setting, so definitely add this to your API when where possible. There's a lot of benefits to it. The other, you'll see here that we have so reauthorized every. This is just the caching on the authorizer, so you can utilize authorizer caching. We've set this to 0 for the purposes of demo, but by all means you can enable caching. So when it comes to request or Lambda authorizers, API Gateway creates the cache key on a key value pair basis, and the identity source is the key. So if we have multiple clients who each have a different API key, and they all use the same authorizer, if we enable caching, API Gateway will actually create a unique cache key for every individual API key sent by the client. So there's no worries of, if Ronan sends his key and the API has caching on it, it's not going to take it off my usage plan, for example. So by all means, feel free to use caching. We've just disabled it for the purpose of the demo.
Yeah, caching is super useful with API gateways. Obviously, most importantly with the authorizers, because there's no need to be, invoking a Lambda function for every single request to come back and say yes, you're allowed in, yes, you're allowed in. But yeah, you do need to consider that cache key and how that is generated, because I know obviously here you're doing it with an API key from the identity, so that that's going to be unique for every single user. But if you did, for example, put it in for a header or some path parameter or something that isn't going to be unique between your users, you could land up caching the wrong response for different users.
Yeah, exactly. And just to note that, as I said, that it's the response, it's the authorizer response that's cached. So that would be, the IAM policy that Ronan mentioned to allow him to invoke the API, any context. I'll talk about that more when we're looking at the code, and the usage identifier key, which is the API key. So this response is cached and then applied to the usage plan.
We did actually have a question that came in. Ankur Tripathi, thank you very much for your question. Yeah, Lambda authorizer returns as IAM role or Boolean. And I suppose the question is, which is the best approach to use?
So I guess here, when you refer to Boolean, you're referring to HTTP APIs, which are the new APIs. So with regards to best approach, I mean, a Boolean is a 1 or a 0, a yes or no. A Lambda authorizer, you have a bit more control maybe over the specific method or the specific resource that the client is accessing. If you're happy enough to just allow all or deny all, a Boolean would be absolutely fine. But if you want a little bit more tighter control, I guess, over what resources or methods the client can access based on the response from the authorizer, then the returning a full IAM policy would probably be better in that regard.
So it gives you more flexibility, but obviously you've got to then generate the IAM policy within the Lambda authorizer rather than just responding with a yes or no.
Yeah, exactly.
I think Zach is going to get onto that too. I mean, in the code, you'll see. Sorry, Julian, I'll field that question.
No, it's fine. Yeah, no, we just had how do you prevent that the Lambda then becomes the bottleneck? Is the Lambda called for all requests? And I suppose the caching covers that. Is there anything else that we should be considering?
Yeah,
for this?
I guess we kind of call that out towards the end of the blog post as well. I mean, in this case, yes, Lambda will be called for every request that has the identity that Zach talked about, because we have to reauthorize every 0, right? So I mean, it's going to be called all the time. If we think about that goal state, right, whereby we're just sending the API key as a header, we have no custom authorizer involved anymore to handle the API key, we're actually getting rid of the Lambda in the middle totally, right? So you shouldn't really see it as a bottleneck, but Lambda is a massively scalable service.
Yeah. And then just one more question while we're in the question, I think, from Andreas. Type equals token means that results in more costs for successfully authored requests compared to API key variant?
I'm not sure I fully get the question.
I was reading
Andreas,
as well.
Happy to, if you want to link up on LinkedIn. I don't have Twitter. If you want to reach out on LinkedIn, happy to chat with you and get back to you.
Yeah. Just on that, Andreas, if you mean by when I talk about the API key variant with regards to the identity source, so token type authorizers don't have an identity source, but when you're creating it, I guess we can talk about that in the console. I can show you. But when you're creating the authorizer, you specify the header, or the token source. It's called actually the token source, and you would specify the header authorization. And it acts the exact same way. Whereas if a request doesn't contain this token source, API Gateway will also reject it with a 401. So I don't know if that's what you are referring to, but you get the same benefit as identity source. It's just called token source in that variant of the authorizer.
Thanks, Zach. Yeah, Andreas, post another question if you do. But yeah, Zach, let's carry on through the template while we don't get too sidetracked. But questions are great, so keep them coming.
Cool. So for our definition body, we've just used a Swagger template. You can use CloudFormation to define the resources and methods. You can use SAM to define the resources and methods. We just like Swagger because it's easy. There's not too much going on here. The one thing I just want to point out is this line here. So line 56. So the x-Amazon API Gateway API key source. This is very important. This is what makes the solution work. So this is the kind of toggle on your API that tells it to not expect it in the header, but to expect it. Oh, that's not good. But to expect it in the authorizer, where we will return the identities or the usage identifier key or the API key. So this is important. If this is set the header and you're returning it through the API key, or through the authorizer, every request will result in a 403 because API Gateway is expecting that header and it's not being sent. So just make sure that this is set to authorizer. With regards to paths, we just have one resource on the API /auth, and we just have one method, which is get. And finally, this is just our Lambda integration. So we're just going with Lambda proxy. You can use non-proxy, proxy. It doesn't really matter. It's completely up to your use case and what you prefer. If you're brave and you like mapping templates, by all means, go with non-proxy and see what you can do with that. So finally, I'm just going to talk about our API key and our usage plan. So SAM offers a resource called API usage plan, which is basically just an abstraction of these 3 resources, where it'll create an API key automatically, it'll assign it to the usage plan automatically, and it'll associate the API to that usage plan. We wanted a bit more control over our solution where we could define the value of the API key. So we kind of just defined all these manually. Not much to talk about here, just we've set our value of the API key, our usage plan. So we've associated it with our API above, our prod stage, and we've defined our throttle limits. So you can define 3 limits on a usage plan. You've got the burst limit, you've got the rate limit, and you've got one called quota. Burst limit is essentially the amount of requests you can send in a single period of time, so 1 millisecond. The rate limit defines how many requests can be sent in a 1 second period, and the quota defines how many requests can be sent in a given period of time. So say 1 week, you're not defining the amount in a second, you're just spreading over like a week or a month or something like that. We've went with 50, which means you can send 50 in a given millisecond, and a request fee of 100, where you can send 100 requests over a 1 second period. So finally, just usage plan key. This is just tying the usage or the API key to the usage plan, so that the client can recognize, or the API gateway can recognize the API key. And we just have the outputs. You'll see this more in the demo when I do it a little bit after. So I'm just going to jump into the authorizer code, Julian, unless there's any other questions on the template.
No questions that come in. I mean, the only thing I wanted to point out is I think that, when you were talking about this being a migration, a big chunk of that Swagger template would be something that you would have exported from your previous API to just import into this. And I know you obviously needed to then connect it to Lambda, which you may not have done before, but that also makes it much easier to be able to migrate to API Gateway, that you just export and import your Swagger templates.
I suppose something to add there as well, guys, would be, like you called out, Julian, very valid point there, that if somebody exports their API from another vendor, it's not going to have that Lambda integration, right? But when I'm working with customers and I see this migration happening, typically they're using something like a HTTP endpoint, right? So it's like a behind a load balancer or something like that as well, which makes it a little bit easier. And then as customers mature in AWS and they start looking at things like serverless, that's when they can kind of really reap the rewards of using things like Lambda. Of course, customers can dive right into Lambda. That's great. But there are other scales as well, which may take more time, and the other integration types just suit better.
Cool, great point, Ronan. So this is our authorizer code. Again, this is where like all the magic happens, where we're taking the API key from the request and returning it via the authorizer response. For this, we've just used the Lambda blueprint, which is available in the Lambda console. We've taken the approach, if it's not broken, don't fix it. This does everything we needed to do. We only made a few minor changes. I'll just talk about them. So the first thing we did is just parse the API key from the event. So the Lambda event is it's essentially the HTTP request from API gateway to Lambda. So as I said, we get things about where the request was sent from, the source IP, who sent it, and all the, request parameters, so query strings, headers, path parameters. We get all this information in the Lambda event, and it's up to us, whatever we want to do with it. So we were just parsing the API key from the query string within the event. Where are we? So that's the first thing we did. The second thing we did was modify this line. So by default, the blueprint allows all resources and all methods. As our API only has one method and one resource, we just tightened this up a little bit to only allow access to these methods or resources. If you have multiple and you want to allow all, by all means you can change this. We just wanted to tighten it up and be a bit more security conscious where possible. So context, this is also part of the authorizer response. So as Ronan said, there's three things you can return via the authorizer. So you've got the IAM policy, which allows access to grants access to invoke the API. You've got context, which is essentially you can return metadata. So if you do some custom logic within the function and maybe reach out to a database, you can return this metadata or extra information that the backend might need via the context. And the final thing is the usage identifier key. So this is the value or the property, I guess, that API Gateway looks for in the response. So we're just assigning the API key that we parsed from the event to this usage identifier key. And then as part of the auth response, we have the key usage identifier key, and we're just returning the value of the API key. And this is essentially how we then apply the API key from the URL to the usage plan that we've attached it to. And then we just return the response, and the API Gateway will either allow or deny the request based on the throttle limits that we defined within the Swagger or within the template, the YAML template. That's the main things. Is there any other questions on this?
Just wanted to add to that as well, Zach. You made a really good point there about the context. So I think we had a question a while ago in terms of which one would you use, right? The Boolean or that other one. I think this is a key thing that you called out, is that context, right? If your backend needs some more information from your authorizer, this is a really nice way to do it. The policy there on line 25. So for example, if we know that Ronan is calling the API and he should only be allowed to access /auth/Ronan and /Zach. We can define that here, or we can say deny everything or allow everything. So it's a really powerful way to control access to your APIs inside this Lambda function.
Cool, thanks, Ronan. The final bit of code I just want to run through is the backend Lambda function. So if all is well, the API key is valid, it's within the throttle limits, this is the Lambda function in the backend that will be invoked. Again, there's nothing special. It's just a hello world Lambda function. Essentially, you have full creative freedom to doing this whatever you want. But this is the response that we should expect to see at the demo. So we'll see hello from Lambda, and we'll just see your IP address. So we'll see 2 values within the response. So are we good to jump into the demo?
Always good.
We can run through this. Yeah, we pray to the demo gods, everything works. So to deploy a SAM template, it's very simple. There's 3 commands. So the first one, well, you can do, even before that, you can run what's called SAM validate, and it'll just validate the YAML to make sure everything's in line. And it's always good to run this before, building it. So once we've validated that the template is fine, we're going to want to run SAM build. So you can run SAM build, or there's another command called SAM build -- container -- use container. So we'll just package the Lambda functions into a container. If you ever experience like runtime issues or something to do with an out-of-date Python version, we'd recommend to use this, as that should alleviate any issues with the runtimes of the Python versions on your local machine.
Yeah, this is super useful. Specifically, you may have Python, but you've got another Lambda function in Node or Go or something. This just pulls down a container, or then builds the SAM function within the container, and basically everything's in there. Super useful. Also, if you are using the new Lambda functions running on ARM Graviton 2, which is super cool, you can get sort of 34% price performance benefit for Lambda functions. If you're running on an x86 workstation, you can actually build ARM functions. Also, just literally don't have to do anything else other than telling the Lambda function it needs to be ARM -- use - container. Job done. Easy.
Cool. Yeah, so now we've, packaged it up and ready to ship it up into AWS. The last thing we need to do is just run SAM deploy, and then just -- guided. If you want to, change the stack name or change the region it's deployed to, but this is essentially what will just ship it up into AWS. So I'm just gonna skip through all these default values, but you have the ability to toggle these and set them to however you want. So this usually takes a few minutes to build. Yeah, we hope that it works and there's no errors.
No, that's fine. Yeah, while that's also going through, there's actually a new part of SAM which is in beta at the moment, called SAM Accelerate. And you can see that this is taking a little bit of time. I know this is the first deploy. If you then were to update your Lambda function, for example, and return something else, this is CloudFormation. It doesn't need to go and redeploy all the other resources, will be fairly-ish quick. But particularly for development environments, sometimes when you're saving code or saving step functions, ASL language, or API gateway Swagger templates, you don't want this can be a bit of a longer process, even though it isn't particularly onerous, can take a little bit longer. So there's actually a new functionality as part of SAM called SAM Accelerate, which synchronizes those code components in the background without you having to do anything. So you make a change to your Lambda function, you just save the Lambda function, and a process runs in the background just to update the code in the Lambda function. You don't need to rebuild, you don't need to redeploy or do anything like that. It just gets handled behind the background, and that makes your local testing super duper quick. So even when Zach says, "Oh, that's going to take a few minutes," that wasn't particularly slow, but SAM Accelerate, and in beta at the moment, it's definitely worth looking at. That can supercharge your local development for Lambda.
Cool. Thank you, Julian. I didn't even know about that, so that's good to know.
There we go.
Yeah, so I guess what we're going to do now is we can just test this in the browser. This is probably going to be quite hard to see, but just know that, where are we? I'm putting this URL for value. I'm just putting this into the browser, and this will just send a GET request to our API, which is the method we've defined. So what we should expect to see when we put this in is we get a response from the backend Lambda function with hello from, I'll zoom this in. We'll see hello from Lambda, and we'll get the source IP. So that's all good. So what's just happened there? If we go back to the diagram at the very beginning, where Ronan talked about, we can see that, so the client sent the request with the query string parameter, the Lambda function parsed it from the event, it applied it to the usage plan via the usage identifier key in the response, API gateway validated it, and we invoked the backend Lambda function. So what we can do as well is we can try and break it. So if the client maybe, I don't know, if someone tried to guess an API key, well, what's going to happen? We're going to get a 403 forbidden. Okay, so what's happened is the Lambda still parsed the event, but it's returned it via the response, the authorized response. The usage plan has said, you know, I don't recognize this API key. I'm going to return a 403 forbidden. And back initially, if maybe there's a bot or something that just finds this URL somehow and it just starts to send malicious attacks and it doesn't know that we have an identity source specified with that query string, if we try to send request at that, we'll get a 401 authorized. And our API isn't going to be built for this, and our Lambda function is not going to be invoked for either of them. So that's a good.
So that's the difference, and I suppose also helpful for troubleshooting. That when you see the unauthorized, you know that's API gateway has responded to tell you that you're not even allowed in. I'm not even running a custom authorized or doing anything. But if you are seeing the forbidden, it has then gone to the Lambda function, done the lookup call in this case for an API key, and come back and said no, not allowed. So that is something, because I know if I've done some testing in Postman and you haven't put anything correct, and you're wondering, well, oh, my Lambda authorizer hasn't fired. Well, you don't even need to check. If you are getting an unauthorized like this, that's a message coming back from API gateway.
Exactly, Julian. Cool. So I guess if we have time, we can jump into the console and just see these resources.
Yeah, let's have a go. I mean, the cool thing about this is it is so easy to show it, and you can think what's happening behind the scenes is super interesting, super helpful for a migration, but not to disparage your hard work on this, but it's actually quite a simple implementation, which is really good, which I like.
Yeah, no, exactly. It's two Lambda functions in an API, you know, and it's a completely seamless migration to the client. So it's very easy to do and very quick to set up.
Yeah, and in fact, that custom authorizer, because I keep saying custom authorizer. Sorry, that's the old term for what Lambda authorizers are now called. But I don't know why today I'm saying that. But bizarre. But the thing is, people are sometimes a little bit sort of hesitant of Lambda authorizers because they think, oh, this is an authorizer I need to write, and you know, especially if it's generating an IAM policy, there's a sort of whole lot of complication. But that Zach did mention earlier that you can actually self-generate these in the console, and the various examples in SAM templates as well. So literally for a basic custom authorizer, you know, they're out there already. You don't have to recreate it from scratch. And it's actually, once you do have a look through the code, it's not a particularly complicated thing to do. And you can see here, even doing something different as, you know, moving where the API keys are coming from, you know, there's only two lines of change, and yeah, not particularly complicated. So don't sort of be put off by Lambda authorizers thinking I've got to now run a whole Lambda function to do my authorization. It's not that much of a thing to wrap your head around.
Yeah, so the Lambda console, which is what I'm showing here, gives us the Python version, but our documentation, our actual public docs, all their example authorizers are written in Node. So if you're a Node developer and you'd rather Node, you can look on our public documentation, and we have great examples for token authorizers and request type authorizers. Yeah, so you've got possibilities to use either languages in that case with good examples. So again, just to run through the API. So if you've never been in the API Gateway console, we have our list of resources. So we have our resource name, which is /auth, and we have our Git method. Before I jump into them, I just want to reiterate one more time about this setting where we specify the API key source. So when we had that flag in our SAM template, this is what we were setting. So we can either set this to header, where API Gateway will expect the request in the x-API-key header, or we can specify authorizer, which is what we've done. So this is where this setting is reflected. And if we jump into the resources, once again, we look at our method. There we go. Yeah, this is essentially the request flow. So this is just where we've integrated our Lambda proxy integration. It sends the request to the backend Lambda and proxies the response back to the client. And that's the magic.
Yeah, that is super great. I love it. Thank you very much. So any other sort of use cases or things people would think about when they are thinking about authorization and API keys and maybe tokens or anything? From either of you, any sort of general recommendations or any tips and tricks from the trenches of how to handle authorization for Lambda? For API Gateway.
Yeah, so Ronan highlighted on immediately, you're not just limited to Lambda authorizers. There's Cognito authorization, which will validate a JWT issued by Cognito. So instead, there's some if you can use a custom authorizer to, call it a no-auth endpoint to check a token's validity. There's quite a lot of code in that involved, and a Cognito authorizer just completely abstracts that for you. So it'll just check the token automatically. If it's a valid token, it'll allow the request through to API Gateway. It's a really easy solution if you do utilize Cognito user pools. I will also go into the authorizers here to show you as well as Lambda authorizers. They're called. There's also IAM authorization, and that's essentially where API Gateway will validate a signature version 4 or a SigV4 request. So that's kind of a signature that your access keys and your secret access keys use to generate, and it's what AWS services communicate with, I guess. So if you have service-to-service communication within your AWS environment, you can enable IAM authorization on the API method, and requests will only be restricted to those that contain a valid SigV4 header or signature.
Yeah, that is super valid. And in fact, everything that has been shown today really would only be for external public-facing APIs. If you have any internal APIs where you have AWS native services calling API Gateway, use IAM, because IAM is ridiculously scalable and large and huge, and that's just so much easier that you can manage your authentication via IAM wherever you can. I mean, that's a general good practice for everything AWS.
Yeah, as well, Julian, I just want to show the question earlier, what I said I would highlight about the two types of authorizers, just to answer the question about which one's better, I guess. So this is our Lambda request authorizer, and this is where I've specified the identity sources. So we can, as I said, we can add identity sources. We can use query strings, stage variables, context, or headers, query strings, multi-value query strings, stage variables, and context. You've got a lot of options, and you can stack them on top of each other. If you've got a request that contains a lot of these. Yeah. With the token type authorizer, you'll see here, you just specify the token source, and this is the name of the header the API Gateway will expect. And if the request doesn't contain this header, then it will also be rejected, just the front door, essentially, and API Gateway won't let it in. So that's just what I was referring to a little bit earlier.
Excellent. Yeah, thanks for showing. Just one more question, Code with Sean. Thank you for the question. If a client is receiving 429, how can I tell?
So again, from a support perspective, we see this a lot. Customers are like, why am I getting throttles, or why is this? So you've got a number of ways to understand what's going on here. So the first one is execution logs. So you'll see where the 429 is coming from. So either if you enable logging, you'll see that either the, I guess, global limit or the regional limit has been hit, which is 10,000 requests per second, or a burst of 5,000. The execution logs will tell you that. Or if the request is being denied due to a usage plan, again, the execution logs will tell you that. For a sort of a general overview, what you can do is you can come to the dashboard. And this is just like a snippet from CloudWatch metrics. So I would recommend to win the CloudWatch metrics. You'll get a lot more better information there and more detailed. But essentially, you can see the number of API calls, the latency, and things like that. If you see the API calls are exceeding any limits, that will be a telltale sign that that's where the 429 is coming from, is either the global limit or the usage plan limit.
Excellent. I don't have any other questions quite yet from the chat, but one thing I did want to ask, seeing we have you, is what are the sort of general things are people calling up AWS support about for API Gateway? What are the things people generally get tripped up with or find confusing or something? What would you sort of give your top tips for API Gateway troubleshooting, or anything really?
Yeah. So again, from a support perspective, we'll always ask for execution logs. They tell you everything you need to know and more. So I mean, very common thing we see is people that have API Gateway front end, Lambda back end, and they're saying, why is API Gateway returning a 5xx? Why is that a 504, for example, gateway timeout? So Lambda timing out is very, very common, I guess. So API Gateway has a integration timeout limit of 29 seconds. So that means by the time API Gateway receives a request, sends it to Lambda, and Lambda returns the response, that needs to be within 29 seconds. So many times customers say, why am I getting 504s? My API is healthy and my Lambda is responding. But little do they know that maybe their Lambda took 35 or 40 seconds to respond. From a Lambda perspective, that will still, return a 200. They'll see in their logs that Lambda returned the response, but the API Gateway will have cut the connection after 29 seconds and returned a 504 to the client. Within the execution logs, we'll get all that information. We'll see, integration timeout or whatever. And yeah, that's a good way to tell. Again, we always point towards CloudWatch. You can see it's called duration in Lambda. You maybe see, 40 seconds, and in API Gateway, you have integration latency. So you'll see spikes. If we see like a lot of spikes up to 29 or 2,900, 29,000 milliseconds, 29,000, that there's been an integration timeout and the back end is taking longer than the default timeout. So that's a very common problem.
Perfect. Yeah, I love that. I love that tip as well. You can also use CloudWatch Logs Insights. That's also super useful because you can bundle up queries across your Lambda functions and API gateways. So if you have a small microservice, and you can view the Lambda logs and the API gateway logs all in one log stream and in Log Insights, and that's also super helpful rather than having to jump back and forth between the various kind of things. So that is super helpful. Well, I just want to, we don't have any additional questions. We do have some comments about, I love the CDK support for API Gateway. So Denny 1111, thank you very much for your comment. The CDK support is super cool. But something I just want to mention is it is AWS reInvent season coming up. reInvent is actually happening in person live in Las Vegas this year. And you also have the option to attend virtually. So that's going to be sort of the best of both worlds. Hopefully, fingers crossed, all travel plans. I will actually be attending in Las Vegas, and I'm doing a talk on serverless observability and a sort of best practices of advanced serverless developers. So certainly please register, use the QR code on the top right. If you are attending in person and there are wait lists and you can't get into your sessions, stick yourself on the wait list because sessions will be moved to bigger rooms to be able to accommodate as many people as possible. Just talking about all the kind of things that we're talking about, SAM today, and also CDK, please have a look at the serverless patterns collection, snippets of code you can copy and paste into your serverless applications. Makes it super easy to go fast with serverless and build all these integrations in an easier way. As I said, reInvent's coming up next week. Eric and I are going to be grabbing some of the top presenters in the serverless track and integration patterns track. No, not integration patterns, the integration services track at reInvent. And they're going to be telling you with a sort of sneak previews of what people are going to be talking about at reInvent. So it's going to be a fun session next week to talk all things reInvent. And in fact, all of Serverless Office Hours during November is all going to be tips and tricks and some of the launches that are coming out before reInvent. Serverlessland.com, of course, everything to do with serverless on AWS. And lastly, I want to just say thank you hugely to Ronan and Zach for a super engaging demo and being super experts and super friendly to be able to answer all your questions on API Gateway. So thank you very much, gents.
Thank you for having us, Julian.
And thank you all for watching. If you're live, thank you for your questions and spending time with us. And if you're doing it on the recording, please, we're also happy to hear any feedback you have. Enjoy the rest of your day, and we'll see you next week for reInvent on Serverless Office Hours.